Let's recapitulate the topic what we have covered in earlier class. We have covered what is a spring and types of spring. There are mainly two types of spring. One is compression spring and other is extension spring. Then see the what types of spring. See the terminology of the spring, where nt is the total number of coil, and total number of coil into dia is a solid length. And see the what is the deflection, what is stiffness. Inactive coils means total number of coil minus active coils. See the this is important style of ends for a helical compression spring. If the plane ends, it means a normal spring which have a number of coil is total number of coil is active. But in case of a plane end, there active coils, total number of coils minus 1, and is in square end and square end is ground type, same, total number of coil minus n. This is the number of active coils, and this is the diagram for the spring. And we see the stress equation. If you open the spring, it looks like a state member, and after that we apply the torsion equation and calculate the shear stress distribution in a spring. So because in there is a condition of if a member is a straight, then we can apply the torsion equation, so that first b state the spring, and after that we apply the torsion equation. See the variation of the this is for direct load, this is for different load. We have covered in a earlier class, so only we are recapitulating. There are two factors, one is direct shear stress, another one is stress concentration due to curvature effect. Because we are trying to do the straight, but there is some curvature in a member, and this is a Wahl's correction factor. And come to the deflection equation. This is also solved by using the stress torsion equation. In after that this is the angle of twist, and see the formula of the angle of deflection. And see the and come to the spring in a series and parallel connection. Because when spring in a series, there is a force is equal, but deflection is sum of the different deflections of a spring. So by using this data, we calculate the stiffness of the spring in a series connection, and just opposite here, deflection is equal to and force is a different in a parallel connection. So we have completed, and come to the what we have we will cover the in this class. Today I will discuss the what is power screw. Power screw is a mechanical device used for converting rotary motion into linear motion and transmitting power. Sometimes you see when change the tire of the car or any vehicle, we use power screw because it converts rotary motion into linear motion and transmit the power. This is a very very popular device to set the tire of the any vehicle. Because let's see the definition. A power screw is also called as a translating screw because it converts the rotary motion into linear motion. There are three essential parts of the power screw. One is screw, and second one is a nut, and apart to hold either the screw or nut in its place. To raise the load in screw jack, to obtain accurate motion in machining operation. For example, lead screw of a lathe, to clamp a workpiece, for example in vice, to load a specimen, for example in a universal testing machine. There is some advantage. A power screw has a large load carrying capacity The overall dimension of the power screw are small, resulting in compact construction. Construction is where load carrying capacity, construction is compact, load carrying capacity is large, and provide large mechanical advantage. Power screw provide precisely control and highly accurate linear motion required in a machine tool application, and designed with a self-locking property. This is a self-locking property means once you set the screw, it doesn't back after allow. And there are some disadvantage, because if we made a component, there is some disadvantage also. A power screw has a very poor efficiency, as well as 40%, and high friction in threads cause rapid wear of the screw, because direct connection between the parts of the. There are different types of threads, because to join the to convert the rotary motion into translate linear motion, we need two threads. So let's see the what types of thread used in a screw. This is a square threads, this is a trapezoidal threads, this is Acme thread. This is similar to the trapezoidal threads, but only difference in the angle. This is 30 and this is a 29, and fourth one is a buttress thread. This is terminology. So thank you so much.